Alright, here we have a problem from 2020 AMC10 number 25. So for this problem we can use two skills. First thing is casework. We're gonna have to use them both anyways. And second of all is stars and bars. So first thing first, let's divide it by case. So let's say D96. Oh wait, even before that, let's do a quick prime factorization. It's gonna be this, right? 2 to the power of 5 times 3, that's gonna be 96. So let's say D96 could only represent it by F1. And that's just gonna be 96, right? And we have one here. And then D26 F1 times F2, and our third case would be D96 as F1 times F2 times F3. You see where this is going? So, okay, let's solve our second case then. F1 and F2, but note that we have a 3 in our prime factorization. That means that either F1 or F2 has to have 3, right? Okay, so what does that mean? And since both F1 and F2, by the way, are larger than 1, that means that at least one, so one of them will have 3 for sure, and then the other will have 2 for sure, right? I mean, this is for sure, right? Because the prime factorization is 2 to the power of 5 times 3, which means that one will have 3 and the other one will have then only be a multiple of 2, right? Because it has to be larger than 1. Notice that it can be, F2 can't be 1. Why? Because in the question it says integers that are strictly greater than 1. So it's gonna include at least 1, 2. So what does that mean? That means that, okay, there are 2 ways of putting 3 and 2 here, right? Either F1 has 3 and F2 has 2, or the other way around, like this, right? So that's 2 ways. So we times 2. And then how many ways? So what other primes do we have left? We have this left, right? Since we used 2 and 3 over here. Now that means that we'll just have to distribute 4 2's in F1 or F2. So we can just do stars and bars here, which is just gonna be 5 choose 1, right? So here we do 5 choose 1, and that's gonna be 10. So for second case we have 10 ways, right? If you guys are familiar with stars and bars, it should be easy, right? F1 plus F2 should have 4 2's in total, right? Disregarding this thing. So either this one has 0, 2, and 4 2's, 1, 2, and 3 2's, something like this. So just 5 choose 1, right? So we have 10 here. And then for our third case, this is just gonna be 3 2 2 or 2 3 2 3 2 2, right? This is gonna be the basis of every case, right? One should have 3, right, for sure, and the other will have 2 for sure. So how many ways are to arrange this? Well, there are 3 ways, but then now we have, since we have already used 2 2's here, we only have 3 2's left, and the number of ways to distribute 3 2's is just gonna be, if you represent it algebraically, it's gonna be 5 choose 2, right? It's just 5 choose 2 which is gonna be 30. And our fourth case, what if D96 could be represented as multiplication of 4 numbers that are larger than 1, of course. So it's gonna be this, right? And how many ways to order this? Well, 4 ways, firstly. And then since we have then 2 2's left, right? Since we use 1, 2, 3 already here. So number of ways to distribute 2 2's in 4 ways and 4 slots. It's just gonna be 5 choose 3, right? It's gonna be 5 choose 3, which is gonna be again, which is gonna be again 40. Here, our fifth case, you know where this is going? F1 times F2 times F3 times, so it's gonna be a representation, multiplication of 5 numbers that are larger than 1. So for sure, one's gonna have F1 or either, I don't know, it could be F2 or F3, but at least one will have 3, right? And the others will have 2 for sure. Why? It should be greater than 1, right? So number of ways to order this is just gonna be 5, right? But then we have to distribute this 1 2. So this 2 here. There's gonna be a left out 2, and the number of ways to distribute this is just gonna be 5, right? Because it can be here, 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 right? So that's gonna be 25 ways. And lastly, what if D96 could be F1 times F2 times F3 all the way to F6? Well, this is just gonna be, right? And that's all of our primes use up. So the number of orderings possible is just gonna be 1, 2, 3, 4, 5, 6, right? 6. So in total, we have 1 here, 10, 30, 40, 25, 6. If you add them all together, what do we have? That's gonna be 11 plus 70 plus 31, just gonna be 112. And that's the answer to this AMC question. If you guys have any more problems that you guys want me to solve, I'll provide you with a lucid and clear solution, step by step, so it's easy to understand. Thank you.